Hello everyone. So today we are solving another question of JEE 2015. This is on the topic of current and electricity. So let's read the question. So they're given an aluminium bar of square cross section and a square hole is drilled and it is filled with iron as shown in the figure. So the electrical resistivities are given, and so basically we have to calculate what is the electrical resistance here. So how will you combine these things, like whether they're in parallel or series? How will you conclude that? So for that, there is simple formula. Whenever they are sharing the same current, it means they are in series, and whenever they are sharing the same potential, they are in the parallel. Here we can see if we apply a battery here, so since they are conductors, so at the both point there will be same potential, which means that they are in parallel. This is the simple concept here. Now we just have to calculate what is the resistance and combine them in the parallel. So for Fe part, so what will be our Fe? It is rho L by A. So what is resistivity of our Fe given here? So it is equal to 10 to the power minus 7. What is the length? It is nothing but 50 millimeters. 15 to 10 to the power minus 3. What is area? Area is nothing but, since it is a square, so 2 or 4 into 10 to the power minus 6 meter square. So if we calculate it from here, so we will get 12.5 into 7, 3, 10 or 10 to the power minus 4 here. Okay, I think this would be enough, or we can convert it into 1.25 into 10 to the power minus 3, I guess. Yeah, now it seems to correct here. Now similarly, if we want to calculate for our aluminium part, so what will be our aluminium? So the resistivity is given as 2.7 into 10 to the power minus 8. What should be its length? It is similar to 50 millimeter, 15 to 10 to the power minus 3. And if we calculate for its area, so initial area was, you can see it was 7 by 7, but we have removed 2 by 2 parts, so it has become 45 into 45 millimeter square basically. So we can write it as 45 into 10 to the power minus 6. Now if we do the calculations here also, so 50 10 times, this goes 9 times, it become 0.3. So 0.3 into 8 3 11 into 10 to the power minus 5. To make it to similar to this term, we can do is, I think I should have made this one in this format. So it was 0. Okay, it was 125 times into 10 power minus 5, and this is 0.3 into 10 power minus 5. Let me check once. I think we missed this 10 one here. Okay, so it will be not 0.3 but 3 times the 10 to the power minus 5. And to make the unit same here, so we can consider it 125 into 10 to the power minus 5. Now, taking 110 to the power minus 5 as common, now we have to calculate for the parallel. We know that if two resistances are common, parallel, so we can write equivalent as R1 R2 by R1 plus R2. Okay, so if we want to do this, so we will get 3 into 125 by 128. Okay, so now if we want to calculate it, 125 into 3 is nothing but it is 375 by 128 into 10 to the power minus 5. Okay, so since we have to tell in the micro, oh sorry, this is mu is 10 to the power minus 6 actually, so we have to convert it to 10 to the power minus 6. So we have to multiply it with 10 here. Now let's resolve all this. So 8 to 10 is 11. Okay, so let's divide for 2. So it will be 64. It will be 5. So 300 to 5 is 1500. 75 is 350. So 1850, 1875, I guess. Yeah, 1875 by 64. So let's see which of the option matches here. Yes, absolutely. Our option B is matching here. And this is our final answer. Thank you, everyone.